In this lesson, we're going to be looking at a little geometry. It's translations and reflections. So what is a translation? If you're looking at your notes, we can fill in the blanks here. A translation is when you slide a figure from one position to another without turning it. The image is the same size and the same shape as the original figure. So back in elementary school, you may have called this a slide. Here's an example. That footprint slid across. It did not turn, and it is the same size and the same shape. The other, what we're going to look at today is a reflection. A reflection is when you flip. The last was a slide. This is a flip over a line. This line is called a line of symmetry. Figures are mirror images of each other. So if you see this car right here, and there in the red line would be the line of symmetry, and the car flips over it, mirror images of each other. It was flipped. So now we're going to look at some pictures from every day, or maybe just some generated pictures, and decide whether you think that they are a translation, which is a slide, or a reflection, which is a flip. Here with the zebras, if I drew a line right here, they're mirror images of one another, so that is a reflection. With this footprint, you can see that it flipped because the big toe is right here and the big toe is right here, so that's not a slide. It flipped over a line of symmetry. This car is sliding across the screen, so that is a translation. Here again you see two footprints with the big toe here and the big toe here. So there was a line of symmetry that it flipped over, so that is a translation. Here with the water, you can see a line of symmetry right here. That is a mirror image of one another, so that is a reflection. Here is a line of symmetry. That car has been flipped, so that is a reflection. If you look here at where the white part is oriented, it just slid across in the same position, so that is a translation. This time with the same shapes, you will notice that there could be a line of symmetry and it flipped right here. So that would be a reflection. There's a reflection. See the flip? This time it's oriented the same way. It's not flipped. It just slid across the screen, so that's a translation. This is a pretty wild looking picture. There's actually, what it is a lady sitting in a corner with mirrors in the corner. And so this would be a reflection. If you choose one of the colors, for example the red, you'll see that it's in the same position. So that is a translation, not a flip. That's a slide. Okay, if you look at the blue right here, it's on the right side. This time it's on the left side. Line of symmetry, that is a reflection. Now we're going to see what this looks like on a 4-quadrant grid. We have an original figure here, a triangle. The first thing we're going to do is we're going to write the order pairs over to the side of the existing shape. So let's call this one right here A. That order pair would be 0, -1, 0, -1. Let's call this one B. This would be 2, -4, 2, -4. And let's call this one C, and that would be 4, -3. 4, -3. Now what we want to do is take this shape and we want to slide it, do a translation. And it gives us the directions up here. It says find the coordinates of the vertices. Vertices are the points where two lines come together. So there are 3 points, 3 vertices. Each point or vertice is translated 2 units to the left and 5 units up. Now, if you recall, the x and y axis is where we go left and right. So when it says 2 units to the left, that means that that's going to change our x. Okay, so right here, for example, we had 0, -1. If we want to translate 0 but go 2 units to the left, here was 0. To go 2 units to the left, we take it to a -2. Then it says it wants us to go 5 units up. Up is on the y-axis. Originally we had a -1 and we want to go 5 up. So that would be 1, 2, 3, 4, 5, which is a +4. Now if you notice what we're doing is we're just taking the original x coordinate, 0, and to do 2 units to the left, when we go to the left, that is negative. So we're subtracting 2 each time. So we went 0 -2 and got our -2. And for the y, we went 5 units up. Up is positive, so we were adding 5 to each one. And -1 plus a +5 is +4. So we're practicing that adding integers that we've been doing. So we call this translation a -2, 5. It tells us that on the x-axis we're going to the left 2 with each one, and on the y-axis we're going up 5, which is a +5. So we call this a -2, 5 translation. So if we do the next order pair, we have 2, but from 2 we want to subtract 2. So 2 minus 2 would be 0. And then for the y, -4, we want to go up 5 or do a +5, and -4 plus 5 would be 1. The next one we have 4. We started with 4, but we want to go left 2, so it's 4 minus 2 is 2. And we have -3, but from -3 we want to go up 5, so that would be up 5. -3 plus a +5 is a +2. So here's our order pairs that we have. Now if you're not comfortable doing the math like that, all you have to do is start with your original point and say go to the left 2, 1, 2, go up 5, 1, 2, 3, 4, 5, and you are at that new order pair -2, 4. This was A. For the next one, we started right here at 2, -4. We're going to go to 0, 1, so we go to the left 2, 1, 2, up 5, 1, 2, 3, 4, 5, and there we are at 0, 1, which is what we said it was going to be. And then on this one, we go to the left 2, up 5, and that takes us to 2, 2. And then we're going to connect them, and you will see that this shape was slid. It was a translation. So we're adding integers to do that, and it tells you up here whether it's going to be a negative. If it's to the left, it's a negative. If it's to the right, it's a positive. If it's up, it's a positive, and if it's down, it's a negative, just like the integer number lines that we've been working on. This is going through the same process here. This is a reflection, so let's see what happens here. We want to reflect this over the y-axis. So the first thing you want to do is make sure you're reflecting over the correct axis. It's either going to be reflected over the x or over the y. It says we'll be reflecting over the y, which is the vertical up and down axis. When you reflect it or flip it, first let's start with our original order pairs. Let's call this A. That is 0, 5. Let's see what my PowerPoint slides are doing here. We'll do it with it so I don't have to write it. We started with 2, 3. So we started with 2, up 3. Okay, the next one was, now if we reflect that, here's what's going to happen. Since we're reflecting over the y-axis, go across here to where the y-axis is. Now how many to the right was it? It was 2 to the right from the y-axis. So to reflect it, we're simply going to go 2 to the left over the y-axis. That's reflecting that point. Our next point, and that would be -2, 3, -2, 3. Our next point is 0, 5. So 0, 5 is right here. It happens to be on the y-axis, so that one's not going to move any. So that one would still be 0, 5. For 4, 5, which is 4, 5, this one right here, look at this one. From the y-axis, it went 4 to the right. So to reflect it, we're going to go 4 to the left. And that ordered pair would be negative 4, 5. Now, look what happened right here. What happened to the coordinates when you're reflecting it? Okay, look what happened. Since we were reflecting over the y-axis, look what happened to the y. It stayed the same. The y of the ordered pairs stayed the same when we were reflecting over the y-axis. But what happened to the x of each ordered pair? 2 to negative 2, 0 stayed 0, 4 to negative 4. Notice that they are opposites. So this is what happened, and you can write this in your notes. What happened to the coordinates when you're reflecting over the y-axis? The x coordinates become the opposite. Now, what happens when you are reflecting over the x-axis? So this time it says x-axis. So we're reflecting over this. That means we're flipping it this way over the x-axis. So let's see what happens. Our first order pair that we're going to look at is negative 1, 2. So negative 1, 2, this one right here. So from the x-axis, it was 2 up. So to reflect it, we're going to go 2 down, and it's going to be right there. Remember, we're reflecting over the x. So if it goes 2 up, we go 2 down, and that order pair would be negative 1, negative 2. The next order pair we're looking at is negative 3, negative 2, this one. It is 2 up, so we want to go 2 down from the x-axis. That would be negative 3, negative 2. The next order pair is negative 1, 4, this one right here. It was reflected 4 up, so we want to reflect it 4 down, which would be negative 1, negative 4. And our last one is negative 3, 5. It went up 5, so to reflect it over the x, we're going to go down 5, which would be negative 3, negative 5. Now, notice what happened when we reflected over the x-axis. Look at the x coordinates. Stayed the same, stayed the same, stayed the same. So when reflecting over the x stayed the same, but something happened to the y's. 2 to negative 2, 2 to negative 2, 4 to negative 4, 5 to negative 5. Now some students would look at that and they would make the conclusion that, oh, it became negative. Well, this time they all became negative, but if it had started down here in this quadrant number 3 and reflected up here, the negatives would have become positive. So instead of saying that the y's become negative, we need to say that the y coordinates became the opposite. If they're positive, they become negative. If they're negative, they become positive. So when reflecting over the x-axis, the y coordinates become the opposites. All right, good luck on your assignment today. Here's your first one, by the way. So what you're going to do is just follow it. It says reflect over the x-axis. Here is the x-axis. So we're going to be reflecting it up here. Remember, when reflecting over the x-axis, that the x is going to stay the same and the y is going to turn to the opposite. So if we pick a point here, and this is 2, negative 2. To reflect it, it went 2 down, so we go 2 up. The x stays the same, the y becomes the opposite to 2, 2. And you're going to continue to do that until you reflect the entire thing over the x-axis.